Welcome back to video 2 of our lesson on similar solids, 15.4. And you should have taken a few notes from the top of page 695 on surface area of similar solids. And a quick reminder, they had a picture there. You may or may not have copied all these down, no big deal. But just to remind you what some of the linear measures or linear dimensions are for the solids that we've been dealing with. And then you took some notes on the surface area of these linear measures, and you said, hey, when two solids are similar, so we're saying the solids are similar, that the ratio of their surface areas is equal to the square of the ratios of their corresponding linear measures. And so that's what this thing right here does for us. This tells us that the ratio of the surface area, so I got surface area of solid A to the surface area of solid B, is equal to the square of the ratios of the corresponding linear measures. So if you look at these two cylinders that they have a picture of for A and B right here, they're saying that the surface area of A to the surface area of B is equal to the square of the ratio between the two radii of the solids. So now it's just a matter of writing that proportion, because that's what it is. It's a proportion, putting in the appropriate numbers, making sure we square and do the math. So let's do a couple and then we'll be done. So right here we have some similar solids, and we're going to find the surface area of the larger solid, and we're going to round to the nearest tenth. So we know that the surface area of the smaller to the larger, that ratio is equal to the square of the dimensions that are the corresponding dimensions, and it looks like they show us the cylinder height. So let's write that down. I always like to start with the dimensions that they give us, and it really doesn't matter how you write this proportion. There's my template, and I'm going to say the smaller one 6 for the height to the larger one 10. And we know that we have to square that. Is equal to the surface area of the smaller one. I have to put the smaller one on top because I put its dimension on top. And they tell us that's 130 feet squared. Is equal to that ratio of the 130 feet squared to the surface area of the larger one. We don't know what that is. That's x. Now we're stuck with doing some math. So the first thing we have to do, following order of operations to do math, is square the ratio 6 to 10. Which means we're going to square both numbers. So 6 squared is 36. And 10 squared is 100. And that's now equal to 130 over x. And so now we do our cross products. And that's 36x. And 13 times 100 is 13,000. Those are equal. Oops, 36x. And then we divide by the 36. Divide by the 36. And we get the surface area of the larger as being 361, and we're rounding to the nearest tenth, so I'm just going to write it down now because it's 11111, a couple down the road. It's 361.1, and of course it's feet squared because we found the surface area. So if you use your calculator, you would find that math to be true. Let's do another one. We're going to just do one more. Not going to do too many of these. Again, these solids are similar. We're going to find the surface area this time of the smaller one, rounding to the nearest tenth. And so we're going to write our template. Oops, I like to use black for my template. I'm going to use black. And just to show you, well, it doesn't really matter. Once again, I'm going to go larger to the smaller, this corresponding dimension. It's the only one they give, so it's got to be the corresponding solid. So the larger is 14, the smaller is 10. The larger, and we need to square that, because remember, the ratios of the surface area is equal to the corresponding dimensions squared. The square of the corresponding dimensions. So we have to square that. And then the surface area of the larger is 294.7. And of course we don't know the surface area of the smaller one. So now it's just up to doing some math. So let's do this. 14 squared. Anybody want to know what 14 squared is? Well, using your calculator, remember I showed you how to do that? You go 14 squared, and that is 196. And then 10 squared, once again, is That's right, it is 100. And so now we have that is equal to 294.7 over x. And then when we do our cross products, you know I like to use green for that, I get 196x is equal to, and then you get 29,470. Multiplying by 100 just moves that decimal over twice, so that's pretty easy to do. And then of course, when you had, all you have to do is divide out by the 196. So you take 29470 and you divide it by 196 and you get 150.35. 153.35, and so this one we can round to the nearest tenth, and our final answer will be 153.4, and our dimensions are meters squared, and so that's how it's done. Proportions, we've done proportions, so we're just taking similar solids instead of similar figures, and we're writing proportions, but we have to know that the corresponding linear dimensions have to be squared. The ratio of those corresponding linear dimensions has to be squared to form this proportion. So now it's up to you to do a quick write. And here we go. It says the ratios of the corresponding measures of two similar cans of cat food is 4:3. So I'm just going to help you out right now. You're making your template and you have your first ratio. You have the ratio of the corresponding linear dimensions being 4:3. And what do we have to do with those dimensions? That's right, we got to square it. Okay? And then that is equal to the surface area. And it says the larger can has a surface area of 100. So I'm going to let you figure out, where does that 100 go? Does it go on the top or does it go on the bottom? And then of course the smaller can goes in the other place. So go ahead and finish that quick write. And you may need to take another quick break. Come back and I'll see you for video number 3 tonight.